In this course, we'll be learning mathematical physics. Mathematical physics is not just mathematics, it is a bridge between mathematics and physics. In this course, we'll basically learn techniques such as vector calculus, differential equation, matrices, which helps us understand physics in a better way. So, mathematical physics is basically the backbone of theoretical physics. It provides maths language and tools which are required to describe physics phenomena. So, let us start off with vector algebra. So, let us start with vectors. Vectors are physical quantities which have both magnitude and direction. So, basically, vectors are tensors of rank 1. Now, coming to scalars, scalars are quantities which have only magnitude and no direction. So, scalars are tensors of rank 0. Now, coming to vectors, example of vectors are velocity, force, displacement, which have both magnitude and direction. Whereas scalars just have magnitude. So examples of scalars will be mass, temperature, speed, distance. Now, let us consider a person wants to go from point A to point B. Now he can follow any path. The straight line path, if he follows from A to B, would be basically displacement, because from while moving from point A to point B, he is not changing his direction, he is moving straight. While if the same person follows a curved path, then in every point, every step, every point of his path, he is changing his direction in order to reach B on time. So this is, now let us name these two paths. Let us name path of the straight line as 1 and path of this curve as 2. Now this straight line path has both direction and magnitude. So it is basically displacement. And what is the value of the displacement? It is basically 2r if we consider it to be a semicircle of radius r. Now the path 2 is basically a semicircle. Now, so distance would basically be pi r, because circumference of a circle is 2 pi r, and so perimeter of a semicircle would be pi r. So we basically now represent a vector as an arrow. This part of it is called the tail and this part of it is called the head. So basically physical quantities are all tensors. Tensors in nature. Scalars are tensors of rank 0 and vectors are tensors of rank 1. Tensors of rank greater than equal to 2 have magnitude and multiple direction. For example, stress, strain, moment of inertia. These are tensors which have magnitude and multiple direction, that is more than one direction. Now for example, consider moment of inertia of a square. Now moment of inertia of this square will be different along this axis, will be different along the diagonals, will be different along this axis. So basically moment of inertia of this square gives different values when its axis changes. This is called multiple direction. Now let us look into some types of vectors. So basically there are many types of vectors, starting off with equal vectors. Equal vectors are vectors which have the same magnitude and direction. So consider a vector A and consider another vector B. They will be considered equal if and only if they have the same magnitude and the same direction. Second type of vector being negative vector. Negative vectors are, consider two vectors having same magnitude but opposite direction. So basically, if your A is this, then B will be opposite to that of A but having the same magnitude. The third type of vector is unit vector. So any vector having unit magnitude and a direction is basically a unit vector. So for example of unit vector would be I cap or j cap or k cap or I cap plus j cap plus k cap by root 3. Why root? Now let us find out why is it by root 3. So if I want to find out the magnitude of I cap plus j cap plus k cap by root 3, what would be its magnitude? I cap's coefficient would be, so what is the formula of magnitude? Coefficient of I cap square under root of coefficient of I cap square plus j cap square plus k cap square. So coefficient of I cap would be 1 by root 3 square plus coefficient of j cap would be 1 by root 3 square plus coefficient of k cap would be 1 by root 3 square. So basically what we are getting is 1 by root 3 plus 1 by root 3 plus 1 by root 3, that is root 1 by 3 into 3, that is under root 1, which is equals to 1. So we have proved that the magnitude of I cap plus j cap plus k cap by root 3 is 1. So it is basically a unit vector. Now coming to the next type of vector. The next type of vector being null vector. What is a null vector? A null vector is a vector which have zero magnitude. The fifth type of vector is cyclic vector. So vectors which follow an enclosed path is basically called a cyclic vector. What will be the example of a cyclic vector? It would be theta cap, because theta follows a cyclic path. Let us now see some operations of vectors. When we talk about operations of vectors, when we basically think of its product rules and addition subtractions. So coming to addition and subtraction, for example, if you are given a vector I cap plus 3j cap plus k cap and you have to add this to another vector, say 2I cap plus j cap plus 2k cap. The rule to add this is basically add the coefficients of I cap. So the coefficient of I cap is 1 plus 2 I cap plus coefficient of j cap is to be added. So it will be 3 plus 1 j cap plus again add the coefficient of k cap. So it would be 1 plus 2. So our answer would be 3 I cap plus 4 j cap plus 3 k cap. For subtraction of two vectors, the same rule follows. Just keep subtracting the coefficient of I cap, j cap and k cap for two vectors. Now coming to the product of vectors. There are two types of products in vector. One is the scalar product called the dot product. Another is the vector product, which is the cross product. Initially starting off with the scalar product. For example, if you are given two vectors A and B, then the scalar product between two of them would be A dot B is equal to modulus of A into modulus of B into cos theta. Theta is the angle between A vector and B vector. Now how to find the angle between two vectors which are given here? Now what we basically do is, angle A vector is aligned in this way and B vector is almost horizontal. So A and B has an angle of theta between them. So this theta of cos theta is basically nothing but this angle theta. Okay. Now coming to again some of the properties of scalar product would be I cap dot I cap is always 1. J cap dot J cap is again always 1. And K cap dot K cap is again always 1. And I cap with J cap, dot product of I cap with J cap is 0. Dot product of I cap with K cap is again 0. Dot product of J cap with K cap is again 0. Why is it so? Because I cap, J cap have a magnitude 1. So mod of I cap, mod of J cap would be 1. But then I cap and J cap represents vector along x and y axis. So the angle between x and y axis is 90 degree in an orthogonal system. So basically cos 90 is 0. So this theta, which is 90 degree, and hence cos 90 degree, makes this dot product of I cap J cap or I cap K cap or J cap K cap 0. So the main culprit is the theta. Now let us represent this dot product in terms of a special function called Kronecker delta function. So overall, this value of I cap dot J cap can be represented as equal to Kronecker delta function delta Ij, where delta Ij is nothing but 1 when I is equal to j and 0 when I is not equal to j. So basically Kronecker delta function is a function which gives a value of 1 when its two variables are equal and which gives a value of 0 if its two variables are unequal. Now let us consider another form of dot product where A is given as AI cap plus BJ cap plus CK cap, and the vector B is defined as Fi cap plus GJ cap plus hk cap. What would be the dot product between a vector and b vector in this case? So what we do here is nothing but multiply its coefficients. That is, we multiply the coefficient of I cap. So what is the coefficient of I cap? For a vector it is a, for b vector it is f. So it would be nothing but af plus, now multiply the coefficients of j cap. It would be b and g plus, now multiply the coefficients of k cap, which would be c h. So this is basically the answer of a cap dot b cap if the form of the vector is this. Now let us try to find some unit vectors. We have been talking about I cap, j cap, k cap. What if a vector like a is equal to ax I cap plus ay j cap plus az k cap is given? We need to find a unit vector of this vector. So how do we find out? Unit vector is a vector which has a magnitude of 1 and just a direction. So basically it has nothing but just a direction. So how do we find a magnitude vector, vector of magnitude 1 from this vector? Nothing but divide this vector with its own magnitude. Then what we will be left with is nothing but magnitude of 1 and just a direction. So dividing this by its, let us go to the next page. So dividing a by modulus of a, that is dividing a by its own magnitude, would give us ax I cap plus ay j cap plus az k cap divided by under root ax square plus ay square plus az square. Alright. Now let us look into the physical meaning of this dot product. For example, if you have to find dot product between two vectors and one being force and the other being displacement, that is, you have a vector which is f and you have a vector which is dr, then what would be the dot product between them? Nothing but simple work done. Force into displacement is work done.